Hi, in this video, I'm going to teach you how to solve logarithmic equations involving ln or natural logarithms. So, take note that natural logarithms are just special type of logarithms. ln means it's a log with a base e. So when we see ln of x, it simply means log base e x. So that means all the properties of logarithms can be used for ln because ln is basically a logarithm. Okay, so in this example, we want to solve a logarithmic equation involving natural logarithms. And it says ln of x plus 2 plus ln of x minus 3 is equal to ln of 2x minus 2. Solving means find the value of x. So when we solve for this, let's copy. Okay, so ln of x plus 2 plus ln of x minus 3 equals ln of 2x minus 2. Just like simple logarithmic equations, we have to take note first of the domain, which is very important because that will already remove any possible answer. Okay, so as we can see, we have x plus 2. We should know that x plus 2 should be a positive value. So that means when we solve for any x, the x must be, so when we solve for this, the x must be greater than negative 2. Otherwise, if you found an x in the solution, that x will not be accepted. In the same way, x minus 3 must also be greater than 0. And that means x must be greater than 3. So as we combine all the restrictions, we can see that the domain of the expression is getting smaller. If we also add 2x minus 2, that means 2x minus 2 to be greater than 0, 2x is greater than 2, or divided by 2, x must be greater than 1. So these are the three things that you have to consider even before you start solving the logarithmic equation. Now to sum up these three restrictions, you can make a number line and place these numbers accordingly. In proper order, we have negative 2 to be the smallest, followed by 1 and then the 3. The x greater than negative 2 means we have an open circle going to the right. The x greater than 3 means we have an open circle at 3 going to the right. X greater than 1 means we have 1 circle on 1 and then to the right. So the summary of the restriction is where these three are the same. They are the same in this portion, and that will start at x equals 3. So the restriction must be x must be bigger than 3. Okay, so take note of this restriction for now. Going back to our equation, we have ln of x plus 2 plus ln of x minus 3 and ln of 2x minus 2. So we need to solve for that after identifying the restrictions. Okay, so let's copy this. Okay. So if you look at the equation, there's a sum of two ln's. And by properties of logarithms, we can make this ln of x plus 2 times that of x minus 3 is equal to ln of 2x minus 2. So here we use the product rule. Okay. There. Now, Whenever we have two ln's, so one ln on one side and one ln on the other side, take note of this idea. If we have ln of A is equal to ln of B, then A must be equal to B. So that makes us, or gives us, x plus 2. We have x plus 2 times x minus 3. This one must be equal to 2x minus 2 because of this idea. It should be correct because whenever two ln's are the same, it means the values here must also be the same. So the logarithmic equation is now reduced to a simple equation, which you will see later on that will become a quadratic expression or equation. So to expand, we have x squared minus 3x plus 2x minus 6 is equal to 2x minus 2. X squared minus x minus 6 is equal to 2x minus 2. And then keep on solving. X squared minus x, this 2x will become minus 2x minus 6, and the minus 2 will become plus 2 equal to 0. Then we have x squared minus 3x minus 4 is equal to 0. Then factor this into x minus 4 and x plus 1 equal to 0. 0. Okay, and finally, x minus 4 must be 0, or x plus 1 is 0, and that gives us x equals 4 and x equals negative 1. Now, again, in any logarithmic equation, do not rush on saying that these are the final answers. Remember that we did something at the beginning that restricted the value of our x by looking at or by considering these three expressions. And from our computation or from our solution, we ended up with the final restriction that x must be bigger than 3. So when we reach x equals 4, or when we reach a solution, x equals 4, it says x equals 4 and x equals negative 1, keep in mind that the x must be bigger than 3 because of the restriction. So one of the solutions will not be accepted. The only x that is bigger than 3 in this between these two is x equals 4, because negative 1 is less than 3. Therefore, the only solution to this logarithmic equation is x equals 4. Okay, to give some context to that idea, if we consider negative 1 as our x, take note that when you replace negative 1 on this x, this will become negative 4, and negative 4 is not allowed. Wherein if we use 4, so here 4 plus 2 is 6, 4 minus 3 is 1, that's okay. 2 times 4 minus 2 is equal to 6, so 6 is acceptable. Okay, so to summarize the solution, again, do not be surprised when you see ln in an equation, because it simply means log base e, and that all the ideas we use for a simple logarithm will be applicable for ln. So product rule, quotient rule, and power rule can be applied in this equation. Okay, so in this particular example, we have a plus sign, so we apply the product rule. So meaning, if this was a minus sign, then you use the quotient rule. It will become a quotient of x plus 2 over x minus 3. So it really depends on the given equation. It's not like you have to use all the properties in every equation. If it calls for a product rule, then you use product rule. If it calls for a power rule, then you use a power rule. If it calls for a quotient rule, then you use a quotient rule. Okay, so that's it.